Okay, so in this lesson, Properties of Logarithms, we're going to talk about the base change formula. And so basically, in this situation, you're going to learn how to use your calculator with to figure out something like this. Find the log base 6 of 2.6, let's say. All right, so you can't do this in your head. You can't say 2.6 to what power 6. There's no way you could figure that out without using a calculator. So we're going to determine how to use a calculator with this. All right, in order to use a calculator, though, we have to talk about something called the base change formula. And so the base change formula is this. If you have, here's a formula, and we're going to kind of attempt to show you where it comes from or how it's derived. But the base change formula you're going to use is going to be this. It'll be the log base b of m is equal to, now, so basically the base change formula, notice in the word, in the base change formula, the words is the two words base change. So you're changing the base. That's what you're doing. So you're going from base b to a different base. And so you can use any base you want, remember, as long as it's positive and it's not 1. You can't have a negative base, you can't have 0 as your base, and you can't have 1 as your base. But you can have any positive number. So as long as you use any positive number, you can change this base to any number you want to. And here's the formula. It'll be the log base m, so the argument's going to go in the numerator, whatever base you want, so I'm going to call it base a, divided by the log of b, so the argument in the denominator is going to be the base here, and the same base that you're looking into, so base a. All right, so I can change this to any base, as long as it's a positive number and it's not equal to 1. All right, so that's the base change formula. So the base change formula says the log of m base b. If you want to change it to another base, you would say the log of m with that new base divided by the log of b with that new base. All right, now where does it come from? Well, let's look at this. So let's kind of determine where this formula comes from. All right, so I'm going to go ahead and look at this for right now. So we had the log of m base b. All right, I'm going to say, I'm going to let that equal x, let's say. And then I'm going to change this to an exponential. So this becomes b to the x is equal to the argument, which is m. All right, now what I'm going to do next is I'm going to take the log of both sides. So you're going to see in the next section, in the next lesson, that to solve some exponential equations, you're going to take the log of both sides. So let's just go ahead and start talking about it now. So I can take the log of both sides, and so it's just an operation, just like taking the square root of both sides, just like squaring both sides, just like raising both sides to the third power. It's just some kind of operation that you can perform. Same thing with logarithms. I can take the log of both sides. Now, remember, I want to take the log of both sides, and I want my new base to be a, so I'm going to call that a. So whatever your base is, let's just call it a for right now. Now remember right here, you remember the power rule. So the power rule says I can take this exponent and write it as a product. So that becomes x times the log of b base a equals the log of m base a. All right, so that's what I have. So all I did was use a power rule to get this right here, and I just wrote everything else over. Now I'm going to go ahead and rewrite this again. To have x times the log of b base a equals log of m base a. All right, now to get x by itself, right now I'm multiplying x by the log of b base a, so the opposite is to divide by the log of b base a. So divide both sides by the log of b base a. And now the log of b base a divided by the log of b base a, that's 1. Those are factors of 1, and so you get x times 1, which is x, equal log of m base a divided by the log of b base a. And so what I found was this. If I go back right here and rewrite this statement, log of m base b equals, remember that's equal to x, and this is now x. So x is this quotient right here. So it's the log of m base a divided by the log of b base a. And there's your base change formula right here. This is a base change formula. And it's very easy to use. I can change this base to any base I want to, as long as it's positive and not equal to 1. Okay. Now, a mistake people make is that where you have the log of a, they want to divide those out. You can't do that. You can't divide those out and say that's m over b. You cannot do that, because that's not log times m. That's not log times b. That's the log of. Of here does not mean to multiply. It's an operation. All right. So you need to be careful. Do not divide these logs base a out. Those log base a's. All right, so that does not mean log times m. That's log of m. That of here is not a multiplication operation. Okay? So the log itself is an operation, so that's not multiplication. Okay, so let's look at some examples, and we're going to see how to use this base change formula. So the first one, so let's suppose you want to find the log of 13 base 5. Log of 13 base 5. Now listen carefully to this. So this says now there, first of all, if you kind of use what we did previously, where you try to do this without a calculator, it's impossible to do. 5 to what power is 13? There's no way you can tell me what that power is. It's not even an integer. So there's no way. It's not even a whole number, I should say. So there's no way you can say 5 to what power. So 5 squared is not 13, 5 cubed is not 13, and so on. So only 5 to a decimal will approximate. So we'll approximate that decimal, but there's just no way you could figure it out without using a calculator. So using the base change formula, this says I can change this to any base I want to. Now listen to what I'm saying. So that saying is this: if I want to change this to base 2, I can change it to base 2, as long as I'm rewriting this side correctly. So remember, it's the log of the argument, that's the numerator, with my new base, divided by the log of, and the base b here is 5, so you gotta say the log of 5 with my new base. All right. But there's still no way, think about this, there's still no way you can say 2 to what power is 13. There's still no way you can say 2 to what power is 5. So you might say, all right, well, I'm going to change this to base b. I'm sorry, base 3. All right, sure, you can do that. So the log of 13 base 3 divided by the log of 5 base 3. So all these right here, there's an infinite number of these. You can change it to base 4. You can change it to base 5. You can change it to base 6. You can even change it to base 2.6. In other words, you can say log of 13 base 2.6 divided by the log of 5 base 2.6. It doesn't matter, as long as your base is positive and not 1. But the point's this: none of this is going to help you. None of these right here helps you. And the reason for that is because, if you recall, when we used our calculator, there's only 2 logs on your calculator. There's this log and there's this ln. So this log, remember, is called the common logarithm. That's my common logarithm function. That has base 10. This right here is my natural logarithm. It has base e. Those are the only 2 bases your calculator uses. Your calculator only uses base 10 and base e. So remember, the calculator only uses base 10 and e. Now, right here, the point I was making here was that there's an infinite number of these things you can use, but there's only 2 of them that's going to help you: base 10 and base e. So what I need for you to understand is this: when doing this problem, you can convert this to any base you want to, but the only bases that's going to help you when using a calculator are these 2. So here's what I want you to do. I want you to rewrite this and say the log of 13 base 5 is equal to, now let's use base 10. So you're going to say the log of 13 base 10 divided by the log of 5 base 10. Now, I wrote the 10 out. It's really not necessary. The only reason why I wrote the 10 out was to emphasize that I am using base 10, but really, log base 10 is just log. So remember, this right here is this, and this is the way we'd prefer you write it. So write it this way. So the log of 13 base 5 is the log of 13 divided by the log of 5. Now remember though, your base is 10, and I can use any base I want to, but I'm going to use base 10 because my calculator uses base 10. So put in your calculator now. So log of 13, so do this now. You're almost done. Log of 13, don't forget to close the parentheses though. That's my numerator. Divided by the log of 5. Log of 5. Alright. Press equal. Don't forget to close your parentheses. Equal. And it's approximately equal to 1.59. So the 2 decimal places. So the nearest, and let's see, they may ask you to round this to the, let's see, round to the nearest, okay, so they're saying nearest 4 decimal places. So 4 to the, round to 4 decimal places. Okay, so that's what direction is supposed to say, round to 4 decimal places. All right, now 4 decimal places means 4 digits behind the decimal point. That's what that means. Okay, so when you go back over here, I've got to redo this again because I only use 2 decimal places. They want 4 decimal places. So the log of 13 divided by the log of 5, close the parentheses, don't forget to close the parentheses, equal, and you get 1.5937. Because remember, you got to look at this place value here. If that's 5 or bigger, this becomes a 7. So 1.5937. Okay? Now, here's something else I need you to remember. Okay, so remember your calculator uses 2 bases, log 10, base C. All right, so I use base 10. So my question is this. Notice I'm still saying equal. This is equal to this as well. So I can remember you can use any base you want to. So let's use base C. What if I instead use this instead, base E? 13 divided by the log of 5 base E. Now remember, just like when we wrote the 10, it is preferable to not write the 10. You don't want to write the 10. Because remember, log base 10 is really just log. So the same thing here. Log base D, based on our previous lessons, is just the symbol ln. So the ln of 13 divided by the ln of 5. See this right here? Log of 13, log of 5. Log of 13, log of 5. Ln of 13, ln of 5. And the question is, am I going to get the same answer? Well, look at this. So the natural log, now this time we're using natural log, so base C now. Natural log of 13 divided by the natural log of 5. And notice what happens. Oops. Alright, so I get the same answer, 1.5937. So I get the same answer. And that would have been true for any of these. All of these, I want you to understand, all of these right here, and there are how many of these bases I can use? There's an infinite number. There's an infinite number of bases. But which ones you're going to use since I need to use a calculator? You're going to use one of these two. It does not matter which one you use because none of these will help you, but these two will. These are the only 2 bases that will help you because they're the only 2 bases in the calculator. Those are the most common ones, so base 10 and base E. So again, it does not matter. It did not matter which base you used. All right, let's go to the next one, number 2. All right, suppose you want to find the log of 87.5 base 14. Log of 87.5 base 14. Now, again, we have to use the base change formula because there's no way you can tell me 14 to what power is 87.5. That's just impossible. So you need your calculator with this. And so remember, you can use, since when you use a calculator, you need to use either base 10 or base E. So here's one thing you can use. You can say the log of 87.5 divided by the log of 14. So the log of the argument divided by the log of the base. Now notice that these bases are base 10. Those are your common logarithms. So you would approximate, or you could have said this, or you could have said natural log of 87.5 divided by the natural log of 14. And you get the same answer. Either way, you get the same answer. So if you type in the log of 87.5, close parentheses, divide by log of 14, close parentheses, equal, you get 1.6944. 1.6944. If you do this one, the natural log this time of 87.5 divided by the natural log of 14, close parentheses, you get the same thing. Okay, 1.6944. Alright, so let's look at one more. So that's all it is. So let's just do one more though. So let's say we had the log of 17 base 0.1. The log of 17 base 0.1. Alright, so that's going to equal, so remember we can use base 10 or base c. So let's use base 10 for right now. So it's the log of 17 divided by the log of 0.01. Oops, 0.1, sorry. Log of 0.1. Alright, so let's see what this is. So the log of 17 divided by the log of 0.1, close the parentheses, press equal, and this time you get a negative 1.2304. Negative 1.2304. And if you had used the natural log, you would still get the same thing. Again, it did not matter which base you used. Some of you may want to use base 10, some of you may want to use base e. So we're going to say the natural log of 17 divided by the natural log of 0.1, and you should get the same thing. So natural log of 17 divided by the natural log of 0.1, and you get negative 1.2304. Alright, and then one more. Let's look at this one. Suppose we had the log of 63 base pi. The log of 63 base pi. Alright, so using base 10, using the common logarithm, I would say the log of 63 divided by the log of pi. And so in your calculator, let's see what this is approximately equal to. So in your calculator, remember our calculator here, so you'd say the log of 63, close the parentheses, divided by the log of pi. There's a pi button, use it right here. There's your pi button, close the parentheses, press equal, and it's about 3.4 decimal places, 3.6193. Since that's less than 5, this stays at 3. So 3.6193. And if you had used the natural logarithm, it did not matter. You get the natural log of 63 divided by the natural log of pi, and you get the same answer. The natural log of 63, close the parentheses, divide by the natural log of pi right here, close the parentheses, press equal, and you get the same thing, same answer, 3.6193. So 3.6193. And that's your base change formula. That's all you do.